Welcome back to Lumicore Labs. Day 19. You've mastered the basics of functions, defining them, passing parameters, and returning values. Today we're going beyond the basics. We'll learn how to accept any number of arguments, how to set default values, and the crown jewel, decorators. Decorators are a powerful way to modify or enhance your functions without changing their code. Let's unlock these advanced tools. Look at this function definition. Name is a regular parameter. You must provide it. But greeting has an equal sign and the value hello. That's a default parameter. If the caller doesn't pass a greeting, hello is used automatically. The function body uses an F string to combine the greeting and the name. Nothing special here. It's the same print logic we've used before. I call greet with just one argument. Name becomes Alex, and greeting uses its default value hello. Now I provide both arguments. Sarah goes to name. Welcome overrides the default for greeting. Here I'm using a keyword argument. Greeting equals hi tells Python exactly which parameter I'm setting. This is super useful when a function has many parameters. 3 calls, 3 different greetings. The function is flexible. It works with or without the second argument. Default parameters make your functions easier to use. What if you don't know how many arguments a function will receive? Use *args. The asterisk collects any extra positional arguments into a tuple. Inside the function, you can loop through args to process whatever was passed. The asterisk before args is the magic. It tells Python, collect every positional argument passed to this function and pack them into a tuple called args. I start with a running total of 0. This is the accumulator pattern we've used before. Start empty, add as you go. Inside the function, args is just a tuple. I can loop through it with a for loop and add each number to the total. After the loop finishes, I return the final sum. The function has processed every number, no matter how many were passed. First call, 3 numbers, sum is 6. Second call, 5 numbers, sum is 150. Same function, any number of arguments. Maximum flexibility. Double asterisk before Kwargs. This collects all keyword arguments, like name equals Alex, into a dictionary. Kwargs is a convention, just like args. .items returns pairs of keys and values from the dictionary. Key gets the parameter name, like name. Value gets what was passed, like Alex. I'm unpacking both at once. I call the function with 3 keyword arguments. The function loops through all 3 and prints them. Name, Alex, age, 25, city, Miami. 3 lines of output from one function call. 3 keyword arguments become 3 printed lines. The function doesn't need to know in advance what keys you'll send. It just prints whatever it receives. This is a decorator. It's a function that takes another function as its argument. Func will be whatever function we apply this decorator to. Inside the decorator, I define a new function called wrapper. This inner function will call the original function and add extra behavior around it. Inside wrapper, I call the original function func. and store its return value and result. Then I convert that result to uppercase and return it. The original function returned lowercase, but the wrapper transforms it before it reaches the caller. The @ symbol applies the decorator. This single line is equivalent to writing say_hello equals uppercase _decorator, say_hello. Python replaces the original function with the wrapped version. When I call say_hello, it goes through the wrapper, gets the original lowercase string, converts it to uppercase, and prints hello, world. The function itself never changed. Only its output was transformed. Let's build a genuinely useful decorator, a timer. It measures how long a function takes to run. We import the time module. The decorator records the start time, calls the function, records the end time, and prints the difference. I'm importing Python's built-in time module. This gives us access to time.time, which returns the current time in seconds. We'll use this to measure how long a function takes. This is our timer decorator. Just like before, it takes a function func as its argument. Inside the wrapper, I record the start time. Time.time gives a precise timestamp right before the function runs. I call the original function. Whatever it does, calculations, waiting, processing, happens here. After the function finishes, I record the end time. The difference between end and start tells us exactly how long it took. I print the time difference formatted to 2 decimal places. This is the performance measurement. The decorator returns the wrapped version. Now any function with that timer will automatically be measured. I apply the decorator to slow_task. This function sleeps for 2 seconds. When called, it'll print, working, wait, and then the decorator will report how long it took. I call the function. It prints, working, pauses for 2 seconds, and then the timer reports. Took 2.00 seconds. You just built a reusable performance measurement tool. Day 19 is complete. You've unlocked advanced function tools, default parameters, Args, Kwargs, and Decorators. These are what separate intermediate Python developers from beginners. In our next and final video, we'll do a complete course wrap-up. I'll show you everything you've learned, where to go from here, and what's next for Lumicore Labs. Please hit the like button and subscribe to Lumicore Labs, and tell me, what would you use a decorator for? See you on day 20.